So you heard a little bit about spec driven development just now. What do I mean by prompt chaos kind of in contrast to that? Well, if you're here, I'm assuming that you've worked with a coding agent before, at the very least with an LLM, and you know that the primary interface for these things still is chat. You might give a little request, you say, I want something. Your agent says, yes, okay, gives you some code. You say, thank you, but not quite. Your agent's like, okay, and it gives you some more code. And this is an important process. This conversation is important. Like, something key is happening here. You're figuring out what it is you actually want to build. And maybe you had a perfectly granular idea of what that was initially, but maybe now you have to work through or around something that the agent can or can't do, or you discover something in the process of building it, and you're like, oh, okay, maybe actually I'll do it this way. Really what's happening here is that you and your agent are speaking two different languages. You're speaking the language of intent, and your agent is speaking the language of implementation, which is code. How many of you are software developers? So how many of you think that writing more code is always the way to solve a problem? Excellent, great. Okay, the answer is that's never really the answer, right? But that's the only language that your agent speaks. And importantly, your side of this conversation is ephemeral. It's not important. It's designed to be disposed of. Some agents literally put this conversation in your temp folder, never to be seen again. And what you're left with is a big ball of implementation code. And somewhere in there is your intent, but code can't really tell you why it's there necessarily. It can't say, I'm a load-bearing aspect of the author's intent for this program, or I'm just here because the author had to hack around something. I'm not really that important. You can refactor me if you want. Code can't tell you that. If you don't document what your intent was, it will be assumed. And I think historically, that's kind of okay, because humans have a lot of ways to correctly assume things. That's why some of us have evolved so well. Not Simon, he'll get there.
You're looking at me.
Sorry. One of the ways that we assume intent is by using stuff. Take this hairdryer, for example. I took this picture and I asked an LLM to make me a sleeker, more modern hairdryer. And it gave me this, and I like it. I think it's sleek and modern, and I like it. However, there are a couple of functional issues here, and they're subtle. That little rubber knob on the side keeps the hairdryer from slipping off the counter. Handy. That sleek little slider, cool until you have hair products or water on your hands, and then it gets sticky over time and it's impossible to use. Annoying. LLMs, famously hairless for now. They don't know this. They'll never use a hairdryer. They don't understand. The same is true in code. Here's a field validation function for a form. If you've never made a form before, you're probably like, what is that set timeout doing there? Until you use the form, and if it's not there, immediately when you type your first character, it's like, that's not a valid email. And you're like, yeah, I understand that M is not a valid email, thank you. LLMs don't care about this either, right? They don't use forms in the same way. They'll happily strip stuff like this out. Now, this is a really trivial UX example, but imagine a code base with a really wide surface area. This kind of stuff is going to compound over time, and this is the most frustrating kind of drift that there is, because this is the kind of stuff that you already thought about and solved at some point, and your agent was like, don't care, not important. You might be thinking to yourself, we've always kind of had this problem. We haven't always documented intent. That's not really what we do as software developers. We write code. Intent and context comes around in things like meeting notes, passing conversations over coffee, documentation, code comments, if you work somewhere that cares about keeping these things up to date. My point is that now we kind of have all that stuff plus these agent conversations, and that's really compounding the problem because that's just you and your agent. And again, these are disposable conversations. So, as well, the consumers of your code base are changing, they're evolving. Whether we like it or not, they are evolving. Of course, other developers are going to see your code. But increasingly, people who don't code are going to see it or approach it. That might sound like sci-fi. It's not sci-fi. It's happening now. I literally just heard the co-founder of Intercom, for example, say that 100% of their designers are expected to push code to production today, even if they have never written a line of code before. Pause for boos. That's been getting boos, by the way, from the crowd. People are scared by this, I understand. Agents are seeing your code base. Agents are pretty smart, but they don't work autonomously. They need you to help. They need a human to be their tech lead. And so when I say agents are consuming your code base, I really mean people leading agents, and those people don't really want to read every line of your code. Even if they want to, they're probably not going to. Also, you in 3 months. If you've ever vibe coded something and then come back to it like a couple months later, you're like, well, who was she? I have no idea. And that might not even be 3 months, that might be like 2 hours. So how do we inoculate ourselves against this problem? I think the answer is to design a narrative arc for your code base in natural language. And I'm going to explain a little bit more about what I mean by that. But I think there's been a lot of sort of industry convergence on this idea of spec driven development. You have a bunch of tools that do this now. You've got Kira by AWS, SpecKit by GitHub, obviously Tessl that Simon is showing. I feel the existence of all these things really concede my point, which is that natural language is now a first-class citizen in your code base. And if it's not, it really needs to be. It kind of is whether you capture it or not. So how do you do that? I think a perfectly defensible way to get started is to just start heavily annotating stuff. Like, this is kind of the simplest example I can imagine. This, by the way, is a module for storage in a broader notes application. And this annotation kind of explains what it does, who calls it, what the downstream effects are. It's pretty compact. If you wanted to get the same amount of context only by reading the code, you would have to traverse quite a lot of files and quite a lot of lines of code to get the same information. So that annotation is doing a lot of heavy lifting there, not just for agents who approach your code base, but for people. Maybe you're working somewhere that kind of already does this, and I think that's nice. That gives you a huge head start. I want to make the case, though, that specs will do a lot of this heavy lifting as well. Here's an example of the same module. And this is a spec. I've done this in a couple of parts because I want you to be able to see the whole thing. And I hope you can see that. But this is an example of a spec that I generated with Tessl. And I feel it has a couple of important load-bearing pieces. So it's got kind of a high level, can you see my cursor? Yeah, okay. It's got kind of a high level overview at the top of what exactly this is. It's got a generate tag. This is like Tessl specific syntax that links to the file, to the code file, to the implementation file that this is describing. And we've got capabilities that are enumerated as testable statements in natural language. If I wanted to, I could have like a test per line here, but that's not how I chose to write this. I chose to use the @test syntax, which is going to create a test based on these things that I've described here at that location. I've got an API. You saw this in Simon's example as well. This is just the interface that I wanted to use. And then importantly, I feel like this is really the part that illustrates my point. This describes all of the other things that this module interacts with, that this spec needs in order to be built in full. In this case, all of these things, all of these @use tags are pointing to other specs. But they could just as well be like internal modules, code files, decision documents, I don't know, external libraries, things like that. The important thing, I feel, is the file linking, which might feel trivial, but it's actually what keeps our specs from getting super, super drifted from their implementation. Like, specs are all well and good, but what are they talking about? Here's an example of how I organized that program and like where the specs live. And this is just one example. I feel just like in code, separation of concerns is kind of a good idea when it comes to specs. I also feel that smaller scoped specs are better, produce better code, produce better results. But this is totally up to you. This whole program could have been one spec, one giant spec. This is how I chose to kind of design that arc of the program. And that leaves me with something that looks more like this. Yes, I still have all of the same implementation code, but it's much easier for me to understand what the author intended for this program because I have in natural language exactly what I expect it to do. What about existing projects? It's kind of nice to talk about specs for like greenfield stuff and stuff that you have it in your mind exactly how it's going to work. But a lot of us work on legacy code bases, or just old projects. I think the bottom line is what you can do literally now is prevent regression from this point on, which is still important. And I would think about kind of working backwards from your implementation code and kind of trying to get the intent out of any source that is available. Where is intent already captured? Things like tests, integration tests, regression tests, end-to-end tests. Not necessarily unit tests where we're like inputs, outputs, whatever. It's less about the functionality and it's more about what is the path the user is taking, or the caller. Decision docs, user-facing docs, PRs, maybe conversations in PRs, commit logs, stuff like that. Slack conversations. It's very hard to explore stuff out of Slack, so good luck with that. Agent conversation history is a really good one. Okay, I'm bored of this presentation. Let's play a game. Where is it? Here it is. Should we scroll through Simon's WhatsApp? Will you guys play Hanging In with me? Do we have time?
Yeah.
Can you give me a letter?
E. T.
S. T. You guys. Elementa. M.
C.
C. P.
Yay.
Great job. Round of applause for you guys. Anyway, this is the Hangman app that I vibe coded. And what I decided to do was make a spec for it because I vibe coded this N amount of months ago. And I wanted to see if I still understood how it worked. So I used something that Tessl offers called the document tool. This is actually taking code and inferring a spec from it. And in this case, I don't know if you can see exactly what I've done. I grabbed my chat log. I made this with Gemini. And I grabbed my chat log and I added an extra prompt here. I just said, I'm going to give you my chat log. Can you make sure that all the core decisions that came about in that conversation are captured here? And I did this twice, once without that context and once with it. Here's an example of one piece of that spec with the extra context. So you guys weren't interacting with the app, but one of the things I cared about was it has to be like keyboard first. I want it to be, you type the letters and then the letters, that's your guess. And you can see user guesses letters by typing. At the very end, you see alphabet buttons are also clickable. It's kind of like an afterthought, yeah, because I meant for the keyboard to be the primary interaction modality. Without the extra context, this is that same capability enumerated. It's like clickable alphabet buttons, also handles keyboard input. Because it's describing the functionality of the thing, right? It's less about the intent for the user's interaction with my incredible, groundbreaking app. I am fundraising, by the way. So I guess what I want to leave you with is this phrase that you've heard 10,000 times in the last 2 years, which is that this is a new era of software development. It's cliche, but it's cliche for a reason. It's cliche because it's true. And it's important for humans to be able to quickly understand implementation code so that they can act as this tech lead for agents. It's also important for agents to understand their working environment. And I feel that documenting intent really does that and kind of future-proofs your code base and your implementation. That's all I have for you. Thank you.